Hello everybody. Today we'll continue our lecture for element of a computer system. Software will be divided into application software, operating system, language processor. Okay? Operating system, which act as an interface, this is operating system, will be interface between the hardware and the user. Okay, between hardware and the user, or between hardware and the application. Okay, like operating system OS, like Windows 10, Windows 8, Windows 7, Unix, Linux, Solaris, Android, okay, Android, Mac OS, and others. This all operating system will be the bridge between the user and application and the hardware. Okay, if the user want anything from any programs or whatever, copy and paste, copy anything, record, listen to music, okay, the operating system will take the order from your application, let's say music or internet. Operating systems, they take your order from your application, then convert it to machine code. This command, your command, will be converted to machine code to be implemented in the hardware. اوكي؟ فأي يوزر من عندكم كان بده حيلا شيء يعمله، يحضر يوتيوب، يحضر فيسبوك، يفتح فيسبوك، يفتح وورد، يفتح اوتوكاد، فوتوشوب، وات ايفر، اي سوفت وير فاتحه، اي سوفت وير، اي ابلكيشن فتحها، اوكي، انت طلبت شغله معينه، اوكي، لتوصل للهاردوير بتوصل 0 1s بالهاردوير ما بيفهم كود، بيفهم 0 1. So الهاردوير only will be implemented zeros and ones. So the bridge between you and application, your application, and the hardware will be operating system. هذه شغلته الأساسية. This is the essential main job for operating system. Okay. History of operating system. Read. Batch processing. Do only one job or task at a time. It's called batch processing. It's an old operating system, like DOS or like Windows 3.1 or before. Will convert one job by one job at a time. Then operating system increase the throughput, حسنوا فيهم وصار أحسن. Later صار في there is multi-programming كمان حسن. بالستينات 1960 كان شيء اسمه time sharing. Please mute your microphone. Please turn off your microphone. Okay. So it's please للكل for everybody turn off your microphone.
دكتور عندك كبسة اول يمكن فيك تسوي مثل الكل.
بهاء يلا. Okay. Yeah. Okay. So this is history how operating system revolution. Read it. This is slide 21 is very important slide. Okay, will be included in the exam. Okay, language processor. What are the language processor? We have three: assembler, interpreter, compiler. Okay, assembler converts the program written in assembly language into machine language or machine code. Assembly language, it's low-level language. Okay? Interpreter will convert from high-level language program into machine language, but by converting it line by line. Okay? Interpreter will convert your code line by line from high-level language to machine language, like program like Python, programming language like Python, it's interpreter. Okay? Okay. A compiler like C, you will learn in this course, like C compiler, also will convert from high-level language to machine language, but in one step. So compiler will read all your codes and give you, if there are errors, at the last will give you where are the errors, and you correct them. Okay, like C compiler. Okay, but Python interpreter, if you have in the line 2 error, example, line 2 error, will stop and give you the error only in line 2. You must correct your error and rerun your code again. Then another error will appear. So if you have errors in your code, interpreter will be slow. But interpreter is faster than compiler if your code is true, because interpreter will go directly into hardware, into conversion operating system to machine code. So in C compiler, like we will use in this lab, in this course, we'll use C. We'll check all your codes. Okay. At the last, we'll give you where are the errors. Line 2, line 4, line 7. You will correct them and run again. Okay. Application software, like any application you have, AutoCAD, Photoshop, Facebook, WhatsApp, game, whatever, called application software. Okay? Now, computer environment, history, okay, or types. You have laptops now. The first personal computer invention was from IBM company, 1981. It is the first personal computer. Okay, for personal computer is the first. But for machine computer, for supercomputer, for big computers, for Army, US Army, was 1950. Also by IBM. But the first computer was in 1950 by IBM, only for military purpose. للحروب. صاروا هن مشان هيك امريكا تفوقت على بالخمسينات ستينات، تفوقت على كل جيوش العالم، لانه عملت كمبيوتر هي قبل الروسيه وقبل الصين وقبل الكل، فحسنت اداء دباباتها وطياراتها وغيرها استعملت فيهم الكمبيوتر، فكرمال هيك ربحت حروب العالميه الثانيه بعتقد او شيء، استعملوا هيك شغله. فبس since 1981 IBM launched the first personal computers to the public. Okay. Later on, you can see we have now laptops, tablet PC, iPad, whatever. Okay. Another thing, now we have internet. All the computers are connected to the internet. Okay. We are the client. We are here. We are the client. Okay. We use internet. Example, if we open YouTube, so we use internet, we use server of YouTube or server of Facebook, Google, whatever. So you are at your home here as a client. You don't have the files, the data. The data will be on the servers of any company you want to watch or to read or whatever, using internet. This is called distributed computing. Okay, another, okay, client-server computing. What is a client-server computing? Here in our lab, or any office, any company, in the university, example lab in the university, they have different computers connected via switch to one server, okay? And this is central storage for hard disk backups. Also, we have printers, sharing printers. So PC1, the user on the PC1 can print on this printer. Also PC2, also PC3, PC4. So this called sharing network. Sharing network, also called client server. This is are the clients. This is the server. Okay. This is background knowledge about computers. Now we'll talk to the language of the computer. Language of the computer or the machine code or whatever, it's zeros and ones. Okay, will be zeros and ones. Okay, how Windows operating system will convert number, any number you type it on the keyboard, to zeros and ones, to binary system, like, okay? So we learn base 10, okay, base 10, it's number system. All of you know it, base 10, from 0 to 9, okay? Base 10 from 0 to 9. All of you learn in the school the base 10, decimal system. It's called decimal number system, base 10. Okay. So the remainder of base 10 are from 0 to 9, also called radix. Sorry, radix is 10, the remainder is from 0 to 9. Okay. Whereas our computers store the data using binary system. A binary number system is base 2. Radix is base 2. We have two choices, zeros or ones. So base 2, we have two choices only. 0, like here, off, 1 on, or 0 low voltage, 1 high voltage. Okay? So inside the computer, all the data will be stored in the hard disk, in RAM, in CD-ROM, DVD-ROM, your video VGA, all the data, video data or image data or text data will be stored as zeros and ones in binary number system. How we will convert from base 10 to base 2? We will learn it today. Okay. Later, we'll learn about octal base and hexadecimal base. Octal system is base 8. Hexadecimal system is base 16. Next lecture on Monday, I will talk about that. Okay, on Monday. Okay, look here. We have decimal system radix 10. The digits, its digits or remainders, if you divide by 10, the remainders will be 0 radix minus 1, okay, from 0 to 9. Binary system, base 2, the radix, the digit will be, or remainder will be 0 or 1 only. Octal system, radix 8, the remainder will be from 0 to 7. Hexadecimal system, the remainder will be base 16, the remainders will be from 0 to 15. But 10, 11, 12, 13, 14, 15 cannot be digits because 10 is 1 0. 1 0, it's 2 digits. It's not 1 digit. For that reason, we replace 1 0, 10, 1 0 by A, 1 11, 1 1 by B, 12 by C, 13, 14, 15. Because the digits must be 1 unit only, 1 digit. 10 will be 2 digits. 1 0 is not 10 in binary system. That's because of that, we replace 10 till 15 by A, B, C, D, E, F. Okay? If we if we want to represent 16 number from 0 to 16. In base 10, it's easy. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It's base 10. Whereas in base 2, it's not. 0 will be 0. 1 will be 1. 2 will be 1, 0. It's not 10. Here, it's not 10. It's 1, 0. We cannot call it 10. 3 will be 1, 1. We will see later. 3 will be 1, 1. It's not 11. 4 will be 1, 0, 0. It's not 100. And so on. Okay? In base 8, we will see 0 to 7 like decimal. 8 will be 1, 0. 9 will be 1, 1, and so on. In base 16, from 0 to 9, similar to base 10, decimal system. 10 will be A, 11 will be B, C, D, E, F, G. Okay? We'll talk about them later deeply. How to convert. Okay. Encoding or conversion. Conversion number. If we have 11 in base 10, 11 in base 10, here we write in the index the base 10, 11 in base 10. How we will represent it in binary system will be 1011. How we get it? Okay. So 1011. This one called most significant bit, MSB, in the left. In the right will be least significant bit, LSB. Okay. This is base 2, as you can see. We convert from 10, base 10 to base 2. I will learn you how later. Okay? So, okay. If we have 2 bits, how many different values? 0, 0, 0, 1, 1, 0, 1, 1. 2 power 2. If we have 3 bits, we have 8 different values. If we have 3 bits, 2 to the power 3, 8. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, whatever. Okay? Okay. Anyone from you take course logic design? Hello?
No,
مش
no.
الظاهر حدا ماخذ مش الظاهر.
Okay. Later I will show you how. I will explain more on Monday. This on Monday I will explain. Okay? Okay, conversion. We'll take to 29, slide 29, conversion. I will convert any number from binary to decimal. How? Multiply, like here, example here. 101, 101. What will be in decimal system? Okay, will be 5. How? So, we multiply the value of each bit by its weight, then add it together. How? 1, 0, 1. First one is the least significant bit. This one is most significant bit from the right. Like ones, tens, similar to ones, tens, hundreds كذا. مثل أحد عشرات مئات ألوف. Okay? فناخد, we take the first in the right, the lowest bit in the right, it's 1, and multiply it by its base. Here it's base 2. So multiply by base 2 times 2 to the power 0. 0 location. Then 0 here, multiply by 2 power 1. 1 location. Last one here, multiply by 2 to the power 2. 2 location. Here's the index 0, 1, 2. The index. We calculate them to get 5. Okay. We'll take another example on Monday. On Monday, we'll take another example. I will search you by hand how to convert. Okay. From binary to decimal, we take the bits and multiply by 2 to to the power location 0, 1, 2 and calculate them. Now the reverse. From decimal to binary, we divide by 10. Sorry, we divide by 2. From decimal to binary, we will divide by 2. Example 5, divided by 2 will give us 2, remainder 1. 2, 2, divided by 2 will give us 1, remainder 0. 1 divided by 2 will give us 0, remainder 1. So we will divide any number in decimal by 2, the quotient by 2, by 2, by 2, till we get quotient equal to 0. Till get quotient equal to 0, we will stop. And we will take all the remainders in reverse order. In reverse order. Okay? From down to up. Here, example 101. We'll take a lot of examples of that. Don't worry. Base 8, octal system number, base 8, the same. It's 2 power 3. Base 16, 2 power 4. Okay. Okay. This slide read not include. This slide not include. Okay. Reading, reading, reading. Okay. Here. Example. Convert the following decimal number to binary form. From decimal to binary. What will make? What will do? 39.
Divide by 2.
Divide by 2. Okay. 39. Look how. 39 divided by 2 will give us how? 1.
19 remainder 1.
Okay. Sorry. 9. It's 400. Sorry. Okay. Okay. 4 times 2, 8. Okay. Minus will give us what? 31. 31 divided by 2. Sorry. Clear all. Again. 39 divide by 2. 3 divided by 2, 1 will give us 2.
19.
Okay. Minus 1 من ننزل التسعة. It's in 19. 19 divided by 2. 8, 7, 9. 9 will give us 18. Okay. The remainder 1. Okay. This is first. This is from our answer. 9. Now equation 19. It's not 0. We will repeat the division. Divide by 2. 19 to 8 will give us 9 to give us 18. The remainder 1. Okay. 9 divide by 2. 4. Okay. Remainder also 1. Okay. 4 divide by 2. 2 quotient. 4 remainder 0. Here remainder 0. 2 divide by 2. 1 will give us 2. Also remainder 0. The last one, 2 divide by 2 will give us 0 to get remainder 1. Okay? So 39 will be like this. From bottom to up will be will be equal here. Okay. Will be equal to, from bottom to up, will be equal 1, 0, 0, 1, 1, 1. Okay? Base 2. Okay? But like index. نكتبها تحت in the bottom. Base 2. So في حدا ما فهمها كيف صارت؟ Do you understand this conversion?
easy دكتور.
وضحت عند الكل؟ وضحت؟ We have still 10 minutes. اوكي؟
لا التاني كبير كتير، كيف نخلصها؟
لا ما تخاف ما تخاف، في طريقة تانية سهلة. We have another method. Monday I will learn you how, and Monday faster method. Not like this. Not like this. Don't worry. Don't worry. But this is the basics rule. This is the basics rule to convert from base 10 to base 2. We must divide by 2 till the end. Divide by 2. The quotient, it's not 0. Divide by 2. Divide by 2 till we get quotient 0. And we get the answer or the result will be in the reverse order of the all remainders. In the reverse order. So here, I don't see the pen. Okay. From bottom to up, from left to right. Okay? From bottom to up, the remainders. We'll take the remainders. From bottom to up, rewrite it from left, from most significant bit, from MSB, most significant bit, to LSB, least significant bits. Okay? From left to right. Bottom to up, from left to right. Okay? This is conversion from base 10 to base 2. أكيد 512 will be كبير. حنعملها. Monday will continue. Now I will do 512. Just 1 minute please.
112 مقسوم على 3.
هلا بنشوف يلا 512 حاعملكم اياها بس ثانية صغيرة بس. اوكي. اوكي. I will share whiteboard. Okay. هذا لوح. It's whiteboard. We have 512. Okay. Divide by 2 will give us 2 times 2 4 minus 1 1 11. نزلنا هذا ال1. اوكي كلكم بتعرفوا ترسموا العاديه. اوكي نزلنا هذا ال1 1 1 divide by 2 5 10 difference 1 نزلنا 2 هلا صارت 12. اوكي 12 divide by 2 6 will give us 12 remainder 0. okay remainder 0. 256 divide by 2. okay 2 1 will give us 2 here. okay 0 okay 0 هون طلع لنا 5 5 divide by 2 2 4 minus will give us 1 بننزل الستة 16 8 8 will give us 16 difference also zeros. 128 divide by 2 will give us 6 because we take these two numbers. 1 less than 2 will take 12 divide by 2 6 will give us 0 here. ننزل 8 4 8 difference will give us also zeros. 64 divide by 2 will give us 32 will give us 64 also 0. 32 by 2 16, 0. 16 over 2, the same, 8, 16, remainder 0. 8 divided by 2, 4, 8, give us 0. 4 divided by 2 will give us 2, 4, also 0. 2 divided by 2, 1, also 0. 1 divided by 2, 0. Here 0 will give us 1. So we'll take from down to up and write it from left to right, like here. So 512 in base 10 equal 1. How many zeros?
9.
9 zeros?
9.
9 zeros in base 2. Okay? This is the conversion. 512 in base 10, if we want to represent it in the binary system, in the computer, in the machine code, in the computer, in the hardware, motherboard, or RAM, or hard disk, will be 1 and 9 zeros. What does it mean, 1 and 9 zeros? 1, which means high voltage. Example, 5 volt or 3 volt. Zeros represent 0 volt, 0 volt, 0 volt, 0 volt, 0 volt. So in the bus, in the motherboard, or in the RAM, in the motherboard, we have wires. Okay? We have wires in the motherboard. In new technology motherboard, we have 64-bit. As you can see, operating system 64-bit, hardware 64-bit. In the old machines, 32. Older, 16. What does it mean? It means we have 64 bits or 64 wires in the motherboard. So we take 10 wire from them to be 100000 in parallel. Okay? So the wire number 10 will be 5 volt, else wires will be 0 volt, 0 volt, 0 volt. All that represent 512 in decimal number. Did you get it? Okay? Did you get it? We have
بيس 10 مشان في 10 digits لكن ناخدها.
ما سمعت عيد شو قلت؟
بنحكي انه بيس 10 ال 512 مشان في 10 digits.
هي عندها 10 digits من 0 ل 9 صح. From 0 to 9. Remainders from 0 to 9 صح. 10 digits. Binary system base 2 عنده 2 digits 0 or 1 هن الريميندرز اللي هون 0 or 1 only 0 or 1. We don't have 2. Okay? 0 or 1 or 1. Low, high. Decimal number base 10 has as remainder or digits from 0 to 9. 10 digits, yes. Okay? Any question for that? For this division? كلكم تعرفوا على هالديفيجن؟
اكيد.
ايه ما في مشكلة عليه. Okay? So we'll continue on Monday. Okay, we'll continue on Monday. Maybe on Monday we'll show you the whiteboard in the lab. I will record myself. Okay? We'll see on Monday that. Okay? For now, we'll finish. Okay? Enjoy your weekend. And on Monday we'll continue with that. Okay? I will stop my recording.